Hello, my name is Nilaranjan and today I am going to introduce on the topic TCP/IP networking. So let's see what is TCP/IP. TCP/IP protocol family consists of IP and TCP. IP stands for Internet Protocol, inside which UTP stands for User Datagram Protocol, and TCP stands for Transmission Control Protocol. Inside it, HTTP and FTP consist. Now let's see what is an internet. A set of interconnected network, global computer network providing a variety of information and communication facilities consisting of interconnected network using standard communication protocols. And the internet is the most famous thing among us. Now see, networks can be completely different, like Ethernet, ATM, modem. These all are the devices through which internet can be connected through us. TCP/IP is what links them. Means TCP/IP is the medium through which these machines are connected with the internet. Router are the devices on multiple networks that pass traffic between them. Individual networks pass traffic from one router or endpoint to another. TCP/IP hides the detail as much as possible. Hmm. Let let's see what the OSI model, also known as ISO model. It's called ISO. That's why ISO released the OSI model, and we don't need OSI model, but for a brief explain on TCP/IP, we are introducing OSI here also. OSI layer consists of 7 network. Physical network consists of cables, data link, Ethernet type of cable, network IP, transport, TCP, UDP, session, presentation, and application. These all are the parts of OSI model. Now let's go ahead and see what are the TCP models. TCP/IP network model consists of 4 layers. First of all, link layer. The data link layer identifies the network protocol type of the packet in the case TCP/IP. It also provides error control and farming. Now the second layer is network. A network access layer. The layer corresponds to combinations of data link layer and a physical layer of OSI model. Means two layer are consisting one layer in network access layer of TCP/IP. It looks out for hardware addressing and the protocols presentation in the layer, and that allows for the physical transmission of data. Now go ahead with layer 3, transport layer. The TCP/IP transport layer protocols ensure the packets arrive in a sequence and without error by swapping and acknowledgements of the data reception and retransmission lost packet. For example, we have entered the data, and the data is converted into packets, and then after the data is sent, uh, then the transport layer will check if the data is sent correctly and assembled correctly. Then after there will be okay. If there will be not sent like transport layer required, then the data will be resended by the transport layer. Now upcoming to the application layer, the application layer defines standard internet and network applications that anyone can use. Now these are the differences between OSI model, TCP/IP hierarchy, and the protocols. See, there are 7 layers in OSI model and 4 layers in TCP/IP hierarchy, in which application layer, presentation layer, and session layer consist of only one layer of TCP/IP, which consists of application layer. Uh, in OSI, transport layer and network layer both are in different. Just like in OSI model, transport layer consists of a transport layer in TCP/IP, and network layer consists of network layer in TCP/IP, both having one equal uh, contribution on TCP/IP. And the first and second layer, that is physical layer and link layer, consist of link layer in TCP/IP. Now I have a look on second here. This is packet encapsulation. The data is sent down the protocol stack. Each layer adds to the data by presenting header. See, this type of hierarchy is made in the packet encapsulation. Application layer, then the data is sent to the transport layer, then the network layer, then the data link layer, then the physical network. Um, uh, let's see what are the consistence of data. First, in application layer, only the data will be there. Uh, then, uh, then after in transport layer, there will be TCP UDP header, and then after the data, then after in network layer, IP header will be added. IP header will be added, and TCP UDP will next to them and the data. In the data link layer, frame header will be added in the packet, and at the end physical network, all the packets will be sized. Like frame header will be of 22 bytes, IP header will be of 20 bytes, and TCP UDP header will be 20 bytes, and the frame trail will be of 4 bytes only. And the length of IP header to the data will be 64 to 1500 bits. Now let's see what is IP. IP is responsible for end-to-end transmission of data. It sends data in individual packets. IP also helps us to maximize size of packet is determined by the network, and IP is unreliable also. Such as the packets we have sent that might be lost, corrupted, duplicated, deleted, or any out of packet, or misconduct of data also be occurred in IP. Now see what is IP addresses. IP address consists of 4 bytes. Example given 163.1.125.90. The IP consists of 4 different parts. Each each device normally gets one or more IP addresses. Means each device will get one packet, two packet, or more different types of packets. In theory, there are about 4 billions available. Means approximately 4 billions IP addresses we are having. Routing. How does a device know where to send a packet? All the device need to know what IP address are on the directly. If the destination on a local host, send it directly there. On the routers connected through the local networks, through the IP packets, they are connected, and the receiving data will be accommodated accordingly. Have the routing is extended and continued. If the destination address isn't local, means if we send the data, and the data we have to send on outside our network, then the most non-routed devices just send everything to a single local network. Means all the things are done in one in encapsulation, and tries to send in one data only. And the another point, the router needs to know which networks correspond to each possible IP addresses. Now IP packets. Source and destination addresses consist of protocol numbers, means 1 equal to ICMP, 6 equal to TCP, and 17 equal to UDP. And IP packets have a various options. Example, to control fragmentation, and the IP addresses are having time to leave. But for preventing routing, this is the IP datagram. Uh, uh, this is the IP datagram, and the IP datagram consists of version, length, time, and total length. Means first 16-bit part is consist of identification, then after three packets of flags, and then after fragment offset. Now in the identification part, there will be time to leave and the protocol, and the from 16 to 31 part, there will be a header checksum, and the total source internet address, destination internet address, options, adding, and the data will be successfully sent. Now IP routing. IP routing consists of source and destination. Like the application transport network and link layer consist under and send to the router, a network and link. Then the router will send same data to the destination as a application transport network and link layer. A routing table. A routing table is just like a destination IP address of a next hop router, and flags and network interface specification. Uh, Now let's see what is UDP. UDP is a thin layer of top of IP. Means UDP is the topmost layer of IP. To find UDP, adds packet length plus checksum. Also, source are and destination are the ports. The ports are used to associate a packet with a specific application at each end. Let's see what is UDP. Now this is a UDP datagram. Uh, See this the source port and the destination port. It consists of only source port and destination port. We have to check length, and then after checksum. The sender sends the length, and the what is the checksum of the data and the application data. Only the data is the received. Now let's see what is TCP. Reliable, full duplex, connection oriented stream delivery. Interface presented to the application that is required in the individual packet. Data is guaranteed to arrive and in correct order without duplication. Means the basic benefit of the TCP model is that the data is taken in a manner way as compared to IP, and the rate of losing data is too much less as compared to IP. And in TCP, that imposes significant overheads. TCP implementation. Connections are established using a three-way handshake, and data is divided up into packets by operating system. Means the dividing data is in the hand of operating system. How the division of packets will be done in TCP. Now the packets are numbered and received packets are acknowledged. Means once the packets are sent to the sender end, the receiver end will acknowledge the packets through numbering. Like packet 1 is sent 1, then the receiver end will be checking they have received the packet 1 only. Then after if they receive packet number 3 or 4 first, then they will merge them and sort in the numbers. And the benefits of TCP implementation is also connections are explicitly closed. Now TCP packets. TCP packets consist of source plus destination ports, include sequence number, acknowledgement number, checksum, and various options. Now, this is the diagram of TCP segment. TCP segment also consists of 31 bits, 0 to 16 source bit, and then 16 to 31 destination port. And after the sequence number from the sender side, then the acknowledgement number, then after the length reserved flags, and after window, after checksum, urgent pointer options, and after 24 to 31 padding, and the whole will be the data. See, this looks like and reverse versions of UDP. Let's move ahead and see this is how TCP transfers data from one node to host. This is the client side to the host side. Let's see. Send packet 1 start timer. So, means on the left we can see the timer is started and the and packet 1 is sent. Now let's assume packet 1 is sent and the packet has been launched. Now packet and the host is waiting for the packet. Now as the packet is lost, the packet isn't received on the host side. Now host will send the acknowledgement to the client that the packet is not received, uh, and send it again like that. Acknowledgement would normally arrive at the time. Okay. Now the times up for the single packet. Now the retransmission of packet 1 will be time started again. Now at this time without losing, the host will receive the data and the host will send the acknowledgement for that host has received the uh, packet. Then after client side receive that acknowledgement one has received to the host. So the timer will be closed for this packet. Now let's have some basic knowledge about IPv6. IPv6 having 128-bit address makes it feasible to be very wasteful and with address allocations. And the lots of other new features are included in IPv6 are in as compared to IPv4, and also built-in auto configuration systems and security options. And the IPv6 is not really in production use yet, and will be seeing IPv6 in future use. Thank you. Have a nice day.